Hello everyone, in this lecture we are going to learn about Annex J and Annex M of API 650. Our flagship courses are Master Static Equipment Design and PVElite, ASME Section 8 Division 2, and Master Welded Storage Tank, as per API 650. We have curated courses to suit your learning needs. So do visit our learning platform for more details on scootoid.thinkific.com.
Annexure J is applicable for shop assembled. What is that? See, whatever tanks you saw earlier, mostly they're all site fabricated because of the size. Now, if your size is small, then and smaller of what? If your size is not more than 6 meters, in that case, you can use or you can fabricate that shell in the shop also. Make sense? So they are called as shop assembled storage tank. Okay, there are lots of addition to the calculation. We'll see that for shop assembled tank. But definitely it will be applicable when purchaser is asking for it. Then only it will become applicable. Or if you want to propose, then propose and get the approval. Make sense? Now how you'll be doing the design? Joint design is again same. Mostly you'll be not allowing lap welded joints because it's a shop fabricated. So you can have a complete butt welded joints. Okay. So all the welds should be butt welded, complete penetration. Okay. So lots of, see now you are trying to make the tank as a pressure vessel. Okay. So you'll see most of the requirements are such that it will make it as a pressure vessel. Bottom plate 6 mm, that is the normal thickness minimum. Okay, and it is saying that bottom plate, whenever possible, okay, like the tank is very small, then you should try to make it in one piece. Don't make it in multiple pieces. For shell design, you'll be using the Annexure A, the optional design basis formula where the joint efficiency is coming. Okay, so that you'll be using for the calculation. Okay, and there is some minimum limit. Like if the diameter is less than 3.2 meter, then the thickness will be 4.8 minimum thickness. For tanks with diameter greater than 3.2, you can have 6 mm or more than that. Mostly self-supported type roof you need to construct. You may have conical type or you may have a dome or umbrella roof. Size of the top angle. Okay. Now, some guideline related to corrosion allowance also. Yeah, nothing much. Lifting lugs. Okay, now in these, see, normally on the tanks, we don't provide lifting lugs because we cannot lift them. But when you're making it in shop, you need to have lifting lugs. Okay. So at least 2 lugs are required. You need to place them at 180 degree. And impact factor of 2 has to be considered for the design of those lifting lugs. Okay. So that is kind of some additional calculation it will be coming. Some changes in the anchoring design. And then testing also. Now here, see, in normal general design, when there is no pressure, you don't pressurize the tank, okay, for testing. But in these tanks, you have to apply an internal pressure of 14 kPa to 21 kPa of the tank when you are testing it. Okay, so this is kind of pressure testing will be required, and air pressure testing. That is kind of additional testing which is there. Examination of shell. If you are following 0.7, then no examination is required. If you are taking 0.85, then spot radiography will become applicable. Okay, that's all in the shop assembled storage tanks. Make sense? So simple things like whenever we are just going through so that you become familiar with that. So when the need arises, you should be able to use that and design it. Now the last annexure, which is Annexure M. When we use Annexure M, when is the use of Annexure M comes? In this Annexure J, radiography is not applicable. No, it can be applicable. But in that case, you'll be taking 0.85 as an efficiency when you are doing radiography. So Annexure M will be used for elevated temperature. And when we say elevated, we are talking about pressure which is exceeding 93 degrees Celsius. Okay, you can go up to 260. So very high temperature. Only changes, the main thing I'll tell, otherwise maybe confusing to you. So the main change what you do in this is using the reduction of the strength. Okay, because when the temperature increases, what changes? What will change in case of increase in temperature? Allowable. Okay. If you modify the allowable, if you have a factor to modify the allowable, it is same as making allowable available to you at the different temperature. So if my temperature is 94, then you'll be using 0.91 MPa based on whatever yield strength I have. Okay. So if my yield strength is more than 380, in that case, 0.92. If my yield is less than 301, then this is what you'll have to follow. For 150, multiply with 0.88, 0.85, 0.8. Once I multiply or reduce the allowable, automatically my thickness is going to increase. Make sense? My thickness is going to increase once I select higher temperature. That is the main point of this Annexure M. That is what the modification which you'll have to do. So select or see that table. What is the multiplication factor? Use that to reduce the yield strength. Okay. And once you are reducing the yield strength, automatically your allowable will reduce. Okay. 2/3 of the yield strength. Okay. So that is what Annexure M talks about. Okay. There is some cyclic calculation which is done. So I'm not going into that detail because it may take more time. It's not required generally. If you see the criteria, it says that when the difference in the temperature is more than 220 among the shell, delta T. Okay, so delta T is not going to be more than 220 because even if I have a 40 degrees Celsius temperature of my tank, so 220 means 260 or more I need to have. Okay, so it very rarely this happens. So you don't need to consider this calculation. If time arises, definitely you can do that. At least you should know that there is something for the delta T. Okay. So that is what is for even the modulus of elasticity we referred also earlier based on the varying temperature you have. Okay, that will be required for the wind girder calculation. Okay. So that is your Annexure M.
For in-depth training. And to learn more about these courses, register with the link in the description.